Okay, so tonight we're starting the next session of this course, which is the force vectors. Yeah, so this topic, like I always say, um, this topic is just an introduction. Rather, it's just a detailed version of what you did in NS. Yeah, so most of the things that you're going to be covering in engineering, I think from second year until you finish your fifth year, you did them in NS, just you did them in physics NX, which was just an introduction. Yeah, so in this time around, we're just going to be going in details. Yeah, so let's see what we have. So in case you want my lines or want to contact me, you can use any of these contacts on the screen, then you reach me. Okay, so let's quickly begin. So these are some of the objectives that we're going to, that we have in this chapter. So we have to, at the end of this chapter, I need to at least to be able to show how to add, you need to be able at least to know how to add forces, resolve them in two components using parallelogram rule, and also express the force and position in Cartesian vector form. And also how to, explain how to determine the vector's magnitude and direction. We're also going to, I'm also going to introduce you to the dot product in order to determine the angle between the vectors or the projection of one vector onto another. So all these things, when you look at them, you did them in NS. So the first part here, using the parallelogram rule, you did this part. So you did an introduction to this part. You also did an introduction to this part, and even this one. For this last part, this last point, you also did this in mathematics, vectors. Yeah, if you remember, there was a topic under vectors, which was on projections. You did these things. And then the dot and cross products, you did all these things. So for me, when I'm teaching, I always assume that you never did anything. That's the reason why I always start from the scratch. I always start from the beginning of everything. I'll explain everything from the beginning. Okay, so let's quickly begin. So we'll start first by defining what a scalar is and what a vector is. And the definitions are all the same. The same definitions that you know are the ones that we are also going to discuss in this course. So a scalar is simply just any quantity that that has magnitude but no direction. Or you can define it as any positive or negative physical quantity that can be completely specified by its magnitude only. It has no direction. Yeah, so examples of scalar quantities include length, mass, and time. Yeah, so there's also this point which says all physical quantities in engineering mechanics are measured using either scalars or vectors. Yeah, it's also an important point. Okay, let's look at a vector as well. So a vector is not really the opposite of a scalar, but it's a quantity or it's a physical quantity that requires both magnitude and direction for its complete description. Or in other words, a vector is simply just a quantity which has both magnitude and direction. That's the simplest version of its definition. And examples of vectors are simply the force, position, and moment. So we're going to discuss the moment. Yes, there was a person who asked me a question early this morning about the moment, though I wasn't online. Yeah, it was showing that I was online, though I didn't see it. I came to see it, I think, when he had already found the answer. Yeah, so we are also going to learn how we can draw the moment and shear diagrams, which I believe a lot of people find difficulties in statics. It's the one that confuses a lot of people. Even the simple things as trusses, they find difficulties to analyze them. So those things are the ones that we're going to focus on very much. So I know the there was the sections in this course which troubles a lot of people. I know them, and I'll know how to explain them in simpler versions. Yeah, more especially traces, how to analyze traces. To me, it was my simplest at my second year, but to a surprise, I discovered that most of the people were complaining on that topic. Yeah, okay, so I know how to explain them in simple ways, in short. Okay, so let's quickly continue. So the length of the arrow represents the magnitude of the vector, and the angle between the vector and fixes, and the fixed axis defines the direction of its line of action. Okay, so this is what they are just talking about in this whole sentence here. So the length of this arrow, if you're talking about a vector, it just represents the magnitude of a vector, and then this tail you're seeing here, and the what is the head, this one, the one that shows the sense of direction of this vector. And then the direction of the vector is denoted by theta, and is found in angles, in short. Yeah. Okay, so when you talk about the vector operations, we're simply just talking about how you can add, subtract, multiply vectors, which is very simple. So when you are multiplying two vectors, or you're multiplying a vector with a scalar, the vector, the solution or the answer will simply just be a multiple of, it will just be that same vector, but it will just be, I don't know how I can explain this, but it will just be, it will just have a multiple equivalent to the scalar that you've multiplied it with. Yes, so it's as simple as that. Anyway, you understand this better when we start doing some examples. Yeah, so most of these things, you know them, so you understand them better when you start doing examples, when you start solving questions. I think I've prepared 2, if not 3 examples in this question, rather in this slide. There's also an exercise which you have to do immediately after having this lesson, and then you submit it before we have the next statics lesson. So this is what is being discussed here. So if you have vector A, with this magnitude, if you multiply it by 2, it's just the same as having these same 2 vectors joined together. If you check the distance from there to there, is almost is exactly halfway of this vector here. And then from there to there, it's another half, meaning we are talking about having 2 vectors there. And then whenever we talk about a negative, when you add a negative in front of this, we're simply just saying that the direction of the vector has changed. Yeah, so if it was going in this direction, it will start going in this other direction. Yeah, that's what it means. If we say half of A, it means that we're dividing this same vector by 2, and this is the result. Okay, so let's quickly look at other things. So I'm rushing. I want us to do some examples because most of these things, you did them in NS, mathematics, and physics. So vector addition. When you're adding 2 vectors, you have, let's say, vector A, which is facing this side, and you also have another vector B, which is facing this side. So what you just need to do is to join the tails of these 2 vectors. So I'm going to join the tail of vector A and the tail of vector B. Then thereafter, I'll draw dotted lines which are parallel. So I'll draw, if this is vector A and B there, so I'll draw this dotted line which is parallel to vector B. And then I'll also draw this dotted line which is parallel to what? To vector A. And then the line that is going to join these 2 vertices of these 2, the same vectors, is the one that we call the resultant vector. So the addition of 2 or more vectors results into what is known as the resultant vector. Yeah, so this is what I'm talking about, and this is what all these points are talking about. So you join the two tails of the vectors, then the solution or the answer is found using the parallelogram law, which is just there to help us to find the resultant vector of the two vectors. Okay. So there's also a special case if you have two vectors that are collinear. When you have two vectors that are collinear, you simply just add them directly. So if you have, let's say, vector A, which is going this side, then plus vector B, which is going this side, simply to find the resultant force, you just have to add A and B. If it's moving in the negative direction, if let's say we have C, okay, let me say B, which is in the negative direction, it means that you are going to have the resultant force as A negative B. So all these things are simple. So I'm just passing. Okay. Then vector subtraction, I've talked about this. When you have a vector that is in the negative direction, simply just have to add a negative in front of that. Yeah. So this is what I was just from talking about. So you have vector A and vector B there. And then if we talk about if we're adding A and negative B, means that you are now changing the direction of B. B will face this side. And remember, when you're adding two vectors, you have to join their tails. So this one will become the tail, and then this one will become the head. So if this one becomes the tail, it means that we're going to combine two tails, the tail for A and the tail for B, meaning this tail will come here, meaning we'll have something like this. And then to find the resultant will therefore start from this point, go this way. Yeah, so this is how you find the resultant of two vectors. So when you have a negative in front of B, that's when you have this case. So this is what they are talking about here. So very simple. And every time you are using the parallelogram law, what you just need to, or your focus should always to come up with a triangle. Let me put it this way. Whenever you're dealing with the vectors and you're applying the parallelogram law, you always have to focus on coming up with an isosceles triangle that you're going to use together with trigonometry to find the resultant vector. So you understand this point when we begin to do some examples. So this is an example of how you add two vector forces. So we have the first force, which is F1 and F2. So adding these two forces, we're trying to find the resultant force, means that we're going to draw a parallel line. Before I display this, let me show you what I'm talking about. So we're going to draw a parallel line, or rather a vector that will be parallel to F1. So it will be like that. And we also have another vector that will be parallel to F2, should be like that. Then we need to find this resultant vector. So the way we find this resultant vector R is by taking one of these triangles. So I can either take this triangle or this other triangle there. So you take one of these triangles and then apply either the cosine or the sine rule to find the value of the resultant force. The resultant force or vector. Okay, so this is what I'm just trying to talk about. You see, there's this line here. Then there's also this parallel line that has been drawn, which is parallel to F1. Then they find the resultant force there. And then this is how you find the resultant force. You have FR is equal to F1 plus F2. So when you see F1 plus F2, it doesn't mean that you just have to add F1. If let's say, for instance, you have, let me make it clear. A lot of people find, this is where a lot of people get lost. So if, for instance, you have 20 newtons this side, or you have 20 kilonewtons this side, you have 30 kilonewtons this side. Finding this resultant vector doesn't necessarily mean that you are going to add F1 plus F2 to find this. You are going to add 20 plus 30 kilonewtons. So in some questions, yes, you may be allowed to do that. but I'm going to show you, okay, yeah, I'm going to show you the proper way in which you are going to identify which method you have to use whenever you've been given any question. Yeah, it's not always that you have to just directly add them 20 plus 30, no. That is not how you do it. You always have to know which is the best, because here, if you have something like this, you first have to form a triangle. You get a triangle. So in this case, they came up with this triangle. And then depending with what you've been given, if you've been given, if you've been given two sides and one angle, it means that you can use the sine rule. Rather, you can use the cosine rule to find the other side. Or if you have been given three sides and two angles, you can use the sine rule. Yeah, so I'm going to show you the best way to solve this kind of questions. So now, how do you find the components of a force if you've been given a force and you don't know the components? How do you find their components? It's also very simple and straightforward. So if you have the force that has been given here, you consider that to be your resultant force, and then they're asking you to find the components. Let's say if this is F, meaning the component in the direction of V will be called FV. The component in the direction of U will be called FU. So how do you find these components? It's also simple and straightforward as long as you have understood the concept that I'm going to teach you. Yeah, so it's simple and straightforward. Okay, so yeah, so this is what I was just talking about. Then you have this triangle here. So from this triangle, you can simply find the value of FV and FU, because you can see them there. So depending on what you've been given, if you've been given angles there, it's easier for you to use either the cosine or the sine rule. Yeah, so this is an isosceles triangle. An isosceles triangle, in case you've forgotten, is simply just a triangle that has all sides different from each other. So this isosceles triangle, it can also be an equilateral triangle, or it can also be a right angle triangle. It can also be apart from it being a right angle triangle, equilateral triangle, it can also be, yeah, actually there are just three. It can also be a scalene. Yeah, it can also be a scalene triangle. I actually made a mistake by saying isosceles has three different, it can also be a scalene which has three different sides. Yeah. Okay, so this triangle you're seeing here is the one that you always have to make sure that you come up with. Yeah, you always have to make sure that you come up with a certain triangle that you're going to use and apply either the cosine rule or the sine rule. Yeah, so the cosine rule, in case you've forgotten, this is the one here. We're going to be using it almost every time we're solving these kinds of questions. And then the sine rule is what you are seeing here. Okay, so let's look at the examples now. So we have an example here on the screen, which says the screw eye in figure 2.11a is subjected to two forces, F1 and F2. And then the question is asking us to determine the magnitude and direction of the resultant force. So these are the types of questions that you are going to expect. But to be honest with you, this is the simplest question you can ever find in statics, in a statics exam or a test. This is the simplest question. So you have to get the basic concepts here, because what we're going to do here as we proceed, when we begin to look at moments and other things, what we're going to do here are simply just going to be basics that we're going to apply to solve questions on other topics. Yeah, so you need to know these things. Okay, so we have, this is, so we have this, this screw eye as described in the question. Then we've been asked to find the magnitude and direction of the resultant force. So the first thing that we need to do is to draw the triangle, the parallelogram. Then from the parallelogram, we're going to get the triangle, which we're going to, with which we're going to use to apply, over which we're going to apply the cosine or the sine rule in order to find the solution. Okay, so let us draw the parallelogram. So we have the first force, that is F2. Okay, let me start with F1. So we have F1 there. We also have F2. So we have F1 and F2. So if you look at this, this one is a right angle, meaning we have a 90 degrees somewhere there. So if I add 10, and then I also add, if I add 10 to 15, I'm going to get 25 degrees. So this 25 degrees subtracted from 90 degrees, this will give me what? It should be something like a 65 degrees. What that means is that this angle here is what? Is 65 degrees. So I'm going to put 65 degrees there. And then apart from that, we have F2 here, which is 150 newtons. Then we also have F1, which is 100 newtons. So from there, let us now draw the parallel sides to make this a parallelogram. So I'm going to draw the parallel line to F1, parallel vector to F1. So it will be like that. Then the parallel vector to F2 will also be like that. So this side, if this is F2, means that this is also what? F2. If this is F1, means that this is also what? F1. So from there, if I've been given this angle as 65 degrees, so if I've been given this angle as 65 degrees, this is a parallelogram. So if this is 65 degrees, we expect this side to also be what? 65 degrees. As long as, okay, let's try to do this. Because we know to say the summation of all angles in, what's this? The summation of all angles in a quadrilateral, in any four-sided polygon, or in any polygon, in short, is supposed to add up to what? In a four-sided polygon, supposed to add up to 360. So we have 65 there. Then if you add it to another 65, we're getting 130. Then we subtract it from 360, we're getting 230. And then when you divide by 2, it means that this angle here is 115 degrees. Even this one here will be what? 115 degrees. I don't know if you have gotten what I've said. Have you people gotten the point here? Do you know what I've done to find 115, 115 and 65, 65 there?
Yes.
All right.
For me, yes.
Okay. So having found these angles, we can now divide this polygon, the parallelogram, into two. So we're going to divide it there. So when we divide it, this line that we've drawn in between here, the resultant vector, is the one that we're calling what? The resultant force. So we're going to call it FR, which is the resultant force. So we can now take one of these triangles and write it here. Let me draw it here. So I'm going to take the one on top. So if I take the one on top, I'm going to have something like this, 150, and then I have another, okay, let me draw it properly. Or let me take the one down, still the same. So I'm going to have the resultant vector there. then I have my F1, then F2 will also be there. So we have F2 there, then we have F1 there. And then this is the resultant FR. And then finding FR, given this angle, which is 115 degrees, then also we've been given what? Two sides. We have 100 newtons. We also have this other side, which is 150 newtons. So we've been given two sides and one angle. Which method are we going to use? So if you look at the two methods that we discussed here, the one which involves only one angle is the cosine rule. Because in a cosine rule, that's why you only have cos of one angle. But if you have two angles or more angles, you can use the sine rule. You can use this rule here. But in this case, we're going to use the cosine rule. So what we're going to do is that we're going to say to find FR. So FR will be equal to FR will be equal to the square root of F1 squared plus F2 squared minus 2F1 times F2. Let me say cos the angle that is opposite to the resultant, or to the one that to the force that we're finding. So the angle that is opposite there is 115. So we can put 115 there in adverse if you want. And then from there, it's just a matter of replacing the figures there. So you put your 100 there. So we're going to have the resultant vector will therefore be equal to, while there is F1 there, I'm going to put 100. Then this will be squared. And then we have F2 will be 150 squared. And then we have minus 2 times 100 times 150. Then we have cos 115 degrees. So from there, you can use your calculator to find the solution here. So after finding the solution for the resultant force, we've been also asked to find the direction of this resultant force. So after finding the solution for this resultant force, you find your answer there using this expression here. So after finding the answer there, it means that you have three sides that have been given, and then the angle has also been given. But remember, we need to find the direction. So how do we find the direction? The direction of this resultant force will be measured from the positive x-axis, meaning we will measure it from there up to there. But from what we've been given here, if we try to find this angle theta here, it means that we've just found what? This part there. So meaning how we need to check from the two trigonometrical rules or laws that, I mean, we need to check from them. We check which one is going to be, which one is going to help us to find this theta here, having been given this side, that side, and one angle. So from these two equations that we found here, the laws, if you've been given multiple sides and one angle, you can use and then you're trying to find another angle. It means that you have two angles, the one that you've been given, which is 115 degrees, and then the one that you're finding, which you don't know. Then you also have two sides, which will be, in this case, I can call them side A and side B. It means that you're using what? The sine rule, because sine rule is the one that involves two angles, the one that has been given and the one that you are finding. So we're going to use the sine rule to find the angle. So this angle that we're going to find there will be theta. So this will just be this part. It will just scatter for this part here. But what of this other part? It means that to find the final magnitude, you need to come and add these 15 degrees here to the answer that you are going to find there. So what I mean is that you can say 115 degrees, or we can start with 150 newtons. So we can say 150 newtons, everything divided by sine theta, because you always take the opposite of the side that you've given, the angle which is opposite of the side that you've been given. So if I'm trying to find this theta here, it means that I'm going to have sine theta there. then we say this will be equal to, then we have the F error that we've been given here. So when you find the F error, if you find F error, let me just assume I've not calculated it. So let me just assume that maybe let's say you found 200 as your F error. So you write your 200 there, and then you put your sine 115 degrees there. So once you do that, you can now just cross multiply and find the value of theta. So after finding your value of theta, you just come and add it to this 15 degrees here, so that you can find the value of the angle from the positive x-axis up to this resultant vector. That is what we are calling the direction of the vector. All right, so do we have any questions before we move on to the next example? Okay, so silence means that it's clear. All right, so these are the solutions. Yeah, so here they found 213. So this is what we did. Okay, so this is what I was explaining. Then to find the theta, you simply just use the sine rule. Then you find your 39.8 there. So I'm going to send this slide so that you can use it for practicing. Then you also add, to find the final direction, now you add the answer that you found to 15 degrees so that you find the direction, which is 54.8 degrees. Okay, so let's take a look at this example as well. So it's also a simple example. This one is asking us to resolve the 600 pounds into its components. So we've been taught to say we resolve this 600 into the U and V component. So in the same way, in the U and V axis. So in the same way, this is a simple question. So we've been given the angles, which are 30 degrees there. So what you just need to do is to draw the parallelogram. So you need to draw the parallelogram, and as you are drawing that, you need to consider this as your resultant vector if you want it to be easy for you to analyze it. So you are going to draw something like this. So you have a U there, you have your U there, then you also have your V. You have your V. So I'm going to draw a parallel line to U. Then I'll also draw a parallel line to V. So now this line which I'm going to have here is the one that is going to be my 600 pounds, which is I'm going to consider it to be my resultant. So having drawn this, we now have to put the angles. So we have a 30 degrees already there. And then if you take, if you check this one here, if we say we have this one there. So this one will be something like this. There will be a 30 somewhere there. There's a 30 somewhere there, 30 degrees. It means that even this part, if you look at it properly, from this angle, you discover that this will also be what? 30 degrees. Yeah, so if you take the Z angle property there, so this will also be a 30 degrees. So this is now easy because you have one side, then apart from having one side, you have two angles, which makes it easier for you to use the sine rule and find the other sides. So we can remove this triangle, which is just going to be like this. So we have a 600 pounds this side, and then we have a 30 degrees angle there. We also have another 30 degrees angle there. So it's easier for us to find these other sides. So I'm going to call this side as side A, side B, and side C. Or let me use the values that have been given there, U and V. So I'm going to call this side as my side for U, FU, and then this this other one, I'll call it the side for what? For FV. Yeah, though I've not drawn it the way you want it, the way this diagram is, I've flipped it a bit. Okay, so yeah, so we can now simply use the sine rule. So the sine rule states that if you have FV, let me start with FU. If you have FU on top there, do you have the angle here? So this one will definitely also be what? So if this is 60, all angles in a triangle add up to what? 180. So meaning this one should be something like a 120. That's why I'm saying I've not drawn it properly. Okay, let's do this. Let me just do this. Let me just display the one that they drew. Okay, so this is what I was talking about. You see, like I said, this angle now, it now makes sense that this one is 120 here. Yeah, it now makes sense because all angles in a triangle have to add up to what? 180. So you remove a triangle like this. So you have 30 there, and 120 degrees there. So the link, I mean, the meeting is going to end automatically. So what we do is that once it ends, you join using the same link so that we continue. Yeah, so that we continue, finish up this question. All right, so we have 30 there, we have 30 there, and then we have 600 there. So it's easier for us to use the sine rule because the sine rule states that if you have, okay, I've even displayed the answer. Okay, FU, okay, let me explain it before I display that. So if you have FU there, then you have the angle there. So you're going to have something like FU over sine what? The opposite angle to FU is 120. So we're going to have sine 120 degrees. Then this will be equal to, you get one of these sides which has